reversible logic gate is a memory-less logic element that realizes on injective logical function. Any gate that preserves the same parity between input and output, then we call it as a fault-tolerant gate. This can be done by using double Feynman gate, Fredkin gate, Feynman gate, new fault-tolerant gate, Islamic gate, and modified Islamic reversible gate too. A reversible circuit without constant on input realizes on all outputs only with balanced function. Therefore, reversible circuit can realize unbalanced function only with additional inputs and a garbage outputs. And we are going to eliminate this garbage output with respect to these Fredkin and Feynman gates. Here is my 2-input Feynman gate. Let me name this input as A and this input to be B, and the output of this to be P, which will be replication of input A, and the output of key, this key which is perform the XOR operation of A and B. So if you could observe the functionality working in such a way that if the input is A here and this will rely on P. Similarly, if there is input B here, for which a combination of this A XOR with B will result to Q. The thing to be observed here is when A is equals to 0, Q is a replication of B. Similarly, when A is equals to 1, Q is a replication of B bar. Here is 0, so the output I am getting is 1, and the input is 1, so output is getting 0. Every linear reversible function can be built by composing only 2 by 2 Feynman gates and inverters. When B is equals to 0, Feynman gate is used as a fan out. Coming to Feynman reversible double gate, here we got 3 inputs. Let me call this A, B, C, followed by 3 outputs P, Q and R. P is a combination of A, Q with A XOR B, and R with A XOR C. And the functional will be as it is: P, which will be replication of A, Q performing the A XOR operation with B, and R performing the A XOR operation with C. Fredkin gate is the most fundamental concept in reversible and quantum computing. Let me assume this input to be A, B and C, followed by P, which is just going to replicate the input of A. P is equals to A, and Q, for which if A then C else B. If A then C else B. Similarly, if I am talking with respect to R, if A then B else C. If A then B else C, and the operation is going to perform as it is. In this gate, the input signal Q and R are routed to the same or exchanged output ports depending on the value of the control signal P. Here is the circuit diagram of an optimal fault tolerant full adder cum subtractor. It contains 3 double gate Feynman gates and a Fredkin gate. For the first Feynman gate, the input B and A with a constant 0 as input so as to make equal number of outputs. Let me give a clarity. A reversible logic gate must have a equal number of inputs as well as equal number of outputs. In order to balance it, I am going to give a constant value to be 0. And the value G1 I am considered to be garbage value. Performance of the XOR operation of A and B will be given to here, which is then fed to the third stage of the Feynman gate. By using this, we are duplicating B input, and A XOR B is the generated one, and B output acts like a garbage output. For the second Feynman gate, a triplicate of Cin is used putting 2 zeros as constant value with Cin at input. One output of Cin will act as a garbage value, and remaining 2 are fed to the one part of the Feynman gate and other part of the Fredkin gate. For the third Feynman gate, the inputs A and XOR B, that is output of the first Feynman gate, and the Cin, the output of the second Feynman gate, and a constant 0, and a fed operation to the exclusive operation of A and B, A XOR with B, that is fed to the garbage value. Finally, the XOR operation of A, B and C is performed here, and the result is given to sum and carry. So this is my A XOR B XOR Cin, which is nothing but the logic functionality of a full adder. It is then fed as input to the Fredkin gate, along with C in of the second FEMON gate and B output of the first FEMON gate. A garbage output value of G4 is considered, which will be a combination of A XOR B. A bar on the carry is generated. Avoiding the garbage values, we can consider the optimal fault tolerant circuitry. This is how we will build a 1-bit full ladder cum subtractor circuit acting as a sum or difference, borrow and ignoring the garbage values and carry.